This is station 2. So I'm going to do this very quickly, okay? I'll go through the formula. So this is the velocity formula, the wave equation, okay? It's velocity equals the frequency times the wavelength. So V is the velocity, obviously, and the units are in meters per second, okay? F is the frequency, okay? And in this class, we use hertz. That's the number of cycles per second, okay? This is the number of cycles per second, or oscillations per second, or vibrations per second, okay? Okay, and the last one is wavelength, lambda. Okay, and wavelength is in meters. Okay, so I'm not going to answer this. So I want you to think about this and answer this question. So you can see the formula here. V equals the frequency times the wavelength. Okay, so now I'm going to look at 4 tuning forks. Okay, and there are 4 different notes. Okay, first one is C. Okay, this is C. I'm going to bang this so you can, I'm going to hit this so you can see it. Okay, or hear it actually. You can see it and hear it. And hopefully you could hear that. Every one of these tuning forks generates a unique frequency because these tuning forks are used to tune pianos and instruments. Okay, this is C, this is B, this is A, and this is F. Okay, so let me write down some information that you need. Okay, so this is going to be C, the note is C, this is B, this is A, and this is F. Okay, I want you to go find the wavelength for these. Well, I'll give you the first 3. How about that? I'll be nice. 67.4 is the wavelength for the first one. 71.8 is the wavelength for the second one. And 80.8 is the wavelength for the third. I'm not going to give you F. I'm going to have you find that. Okay? Then the frequency of this is written on each one of the tuning forks. Okay? Now you don't have these, so I'm going to write these down for you. The frequency for C is 512 hertz. The frequency for B is 480 hertz. The frequency for A is 426.7 hertz. Okay? And then I'm going to give you the frequency for F, but not the wavelength. 341.3 hertz. Okay? Now what do you need to do? You are going to use the wave equation to find the speed of sound. Regardless of the frequency and the wavelength, the sound traveling from this tuning fork is traveling at the speed of sound in the air. Okay, about 343 meters per second, give or take. Okay? And so basically I want you to calculate with these wavelengths and frequencies the speed of sound. You should get the same or a very similar number. You're going to use that speed of sound then to calculate the wavelength of F. Okay? Okay.